Okay, this video is about similar figures and solving for the missing side lengths using scale factor. So similar figures are figures that are the same shape but different sizes. All corresponding sides have equivalent ratios. They can be written as new to original with the colon like that. We can have new over original in the fraction or new to original. Those are all the ways that we can write our ratios. I prefer the fraction. All right, so we have this first triangle. The original is on the left and the new is on the right. We can see right now that it gets smaller, or I'm sorry, it gets bigger going from original to new. So I always like to start by labeling my corresponding sides, or at least highlighting them or putting a shape around them so I can be sure that I am using the right numbers. We want the corresponding sides to go together. So the same side length, the same side of each of our shapes. So my shortest sides were 6 and 3 on the new and the original. And we always write it as new over original because that is going to give us our scale factor. We want it to give us our scale factor and not the inverse. So we have 6 over 3 as one. With my 6 and my 12, I have 12 over 6, 14 over 7, and 4 over 2. Now if I simplify all of these, they're all equivalent to 2 over 1, or just 2. So my scale factor is 2, because when I take any of those side lengths on the original and multiply them by 2, I get the new side length. So 3 times 2 is 6, 6 times 2 is 12, 7 times 2 is 14, 2 times 2 is 4. All right, here is my next shape. We have our five-sided figure here, and some of the side lengths are labeled. So I have, luckily for me, this shape has the sides, I'm sorry, the orientation is in the same direction, so I can just label the same spot on each side. And so I do notice right now that I have X as the base of the new shape. So I'm going to have to solve for that. But first I need to find the scale factor. And I'm looking at both of these. And my new is 1 1/4. My original is 5. For the yellow, my new is 1. My original is 4. And looking at those two ratios, the 1/4 is going to be a little bit easier to work with. I can find a decimal of either one of these. Both of these come out to be 0.25. But what I want to do is then take my original 8 and multiply it by my scale factor. So 1/4 or 8 times 0.25, and I'm going to get 2 either way. So 2 is X, my scale factor is 1/4 or 0.25. There's one more way that I can solve this. This one was nice and easy to just do 8 times 0.25 or 8 times 1/4. But we do want to make sure that if it's not a very nice decimal when we type it into the calculator, we're not using a rounded version of it. So I could also do 1 over 4 is equal to what over 8? And I can use my giant 1 4 times 2 is 8, 1 times 2 is 2, so x equals 2. We get the same answer either way, but there are a few options for you for how you get to solve. All right, my last one. Once again, I have two shapes. This one's getting smaller. So here's how I'm going to do this one. I have 3 to 5 as my new over original, so it is the same as 0.6. I could take my new and multiply by 0.6, so to find y, I can do 8 times 0.6. Or I could do 3 over 5 is the same as y over 8. Either way, 8 divided by 5 is 1.6. So I could do 3 times 1.6. And I get 4.8. Or I can do 8 times 0.6. I also get 4.8. So y equals 4.8. Going to do the same thing with x. This time x is the original, so I would do 3 over 5 times 6 over x. 3 times 2 is 6, 5 times 2 is 10. So x is 10. I could also do that by doing 6 divided by 0.6. I would also get 10. And my scale factor is 3/5 or 0.6. So lots of ways that you can solve these problems.